All these computers you use, all the tablet you want to use and the smartphone you want to have, all those things are driven by very smart electronics. There's little chips that do all the calculations and they make all the things happen on your screen.
Our lives are extremely influenced by integrated circuits. They're really all around us.
The heart of every computer chip is this transistor, this device that enables the switching of electrical currents on the circuit. Nowadays, they're trying to pack as many of these devices into a computer chip as possible.
This is only made possible by an extreme shrinkage of the dimensions.
The smaller you can make them, the faster they become, the more energy efficient they become. At some point, it's hard to make things even smaller than this.
Transistors started with a millimeter size that was huge, and now it's in nanometers. We're really approaching the fundamental limits, and we still want to go beyond them.
How do I know where stuff is printed, and how do I know how well it was aligned on top of each other?
What they do is they shine this extreme ultraviolet radiation onto a silicon wafer. How do you best produce this radiation that's then used to make these little tiny patterns on computer chips?
That is basically the challenge that we set ourselves. We work in an institute for nanolithography, and what that is basically the science to make very small features as you see in the semiconductor industry. We have multiple groups specializing on different parts of the same problem.
It goes from engineering, mechanical engineering, to condensed matter physics, to atomic physics, to optical physics, and also a whole lot of chemistry that goes in there.
And it's only through this collective effort, really, that you can make a big impact on this technology.
Become more than the sum of parts, essentially.
It's still an extremely challenging problem. A lot of science needs to be done, but we always have the application goal in mind.
At ARCNL in general, we have a very, very good combination of asking deep fundamental questions that are linked to an actual application.
Chips drive the world around us. Being able to manufacture better, smaller, faster, greener chips. Technology that leads up to that, I think, is worth doing research on. And that is what we're trying to be part of.
What we really contribute is the, what some people say, the fourth revolution of our society.
All of the beautiful physics in there is just, yeah, shocks me every time that it works.